Hi, I'm Mr. Smith.
And I'm Angel.
And we're here to help you get ready for the geometry STAR test. We're using the STAR release problems. We're going to start with Standard 1. Standard 1 says, students demonstrate understanding by identifying and giving examples of undefined terms, axioms, theorems, and inductive and deductive reasoning. So that's a lot of stuff. If you look at this chart, it tells us that Standard 1 is dealt with in problems 1, 2, and 3. So right now we're going to do problems 1, 2, and 3 out of the packet. So let's start at the first one. This is problem 1. It says, which of the following best describes deductive reasoning? So we got this word deductive. Deductive tells us that we're going to use logic, known information, to find new information. So let's find the one that sounds like that. So A says using logic to draw conclusions, that sounds like new information, based on accepted statements. So that's known information. So that sounds really good. Okay, let's see if anything's better. Accepting the meaning of an item without definition, that just sounds like bad idea. Defining mathematical terms to correspond with physical objects. That's not deductive reasoning. Inferring a general truth by examining a number of specific examples. This is actually inductive. Inferring a general truth. In other words, using a series of observations to come up with the general idea. That's inductive, but we're looking for deductive. So I'm going to go with A, using logic to draw conclusions based on accepted statements. Do you agree, Angel?
Yep.
All right. Number 2, in the diagram, angle 1 is congruent to angle 4. Well, the first thing you should ever do is, if you have some given information, is to mark it immediately, because it helps you solve the problem. Okay, which of the following conclusions does not have to be true? So A, angle 3 and angle 4 are supplementary angles. Well, here's angle 3 and angle 4. As we can tell, they're vertical angles. So they're definitely congruent, but they're not necessarily supplementary. So this is probably not true. So I'm going to say that that's probably the answer, because after all it says does not have to be true. So that doesn't sound likely. I think that's probably the best answer in that case. Line L is parallel to line M. Well, let's look at this. If 1 and 4 are congruent and they are alternate exterior angles, when alternate exterior angles are congruent, the lines are parallel. So that does have to be true, which means that cannot be the answer. Angle 1 is congruent to angle 3. Well, again, if these are congruent, then the lines are parallel. And if that's true, then corresponding angles, like 1 and 3 are corresponding, that also has to be true, so therefore that cannot be the answer. And last, angle 2 is congruent to angle 3. Well, angle 2 and angle 3 are alternate interior angles, and again, if the lines are parallel, which is true because the alternate exterior angles are parallel, then the alternate interior angles have to also be congruent. So that can't be the answer. So the answer, again, is A. Angle 3 and angle 4 do not need to be supplementary. They're definitely congruent. The only way they would be supplementary is if they're both 90. So the answer is A. Last, consider the argument below. 1, every multiple of 4 is even. Okay, so all multiples of 4 are even. 376 is a multiple of 4. Therefore, 376 is even. Well, what we did here is we took a fact and a second fact, and we drew a conclusion. If we go back to number 1, that said using logic to draw conclusions based on accepted statements is deductive reasoning. So it sounds like this is deductive. So I'm going to say that looks like deductive. Let's look at number 2. A number can be written as a repeating decimal if it is rational. That sounds like a rule. The second one says pi cannot be written as a repeating decimal. That sounds like another rule. Therefore, pi is not rational. A conclusion based on 2 rules that also sounds like deductive reasoning. So which ones, if any, use deductive reasoning? They both do. Both 1 and 2 use deductive reasoning because they both use rules to draw a conclusion. Okay, thanks a lot. So that was standard 1.0 of geometry from the STAR release packet. Tune in for all the other standards. We'll do 2 through 22 coming soon. Thanks. All right, welcome everybody. We're doing STAR release problems. We're doing standard 2. I'm Mr. Smith.
And I am Angel.
and we're here to help you solve your STAR problems. So right now we're looking at Standard 2. Let's examine what it says. Standard 2.0, students write geometric proofs, scary word, proofs, including proofs by contradiction. So if we look here, Standard 2.0, that is these problems here, so that would be 4, 5, 6, and 7. So we'll be doing 4, 5, and 6, and 7 from the STAR packet. Okay, let's start with this one. Theorem: a triangle has at most one obtuse angle. Eduardo is proving the theorem above by contradiction. That means he's going to try to say something against it and then prove that that part is false. He began by assuming that in triangle ABC, angle A and angle B are both obtuse. That means each one of them is more than 90 degrees. So he's saying that angle A is greater than 90 degrees, and he's also saying that angle B is greater than 90 degrees. Which theorem will Eduardo use to reach a contradiction? So basically, if they're both more than 90, just think about it for a second. If they're both more than 90, then that would add up to more than 180. But we know triangles add up to 180, so this could never happen. Okay, so let's look for something that goes along with that logic. If two angles of a triangle are equal, the sides opposite the angles are equal. Well, that's not related. It didn't say A and B are equal. It just said that they're more than 90. So that is definitely not the answer. B, if two supplementary angles are equal, again, nothing here is equal, the angles are each measure 90 degrees. Completely irrelevant to what we're reading. C, the largest angle in a triangle is opposite the longest side. Well, that's true, but again, it's really not relevant. I think it's going to have to be D. The sum of the measures of the angles of a triangle is 180. There it is, because if A is greater than 90 and B is greater than 90,
291.
then A plus B is greater than 180. And that's without even having C in there. So if it has to add up to 180, then only one of them can be more than 90, or it'll be too big. So that's the problem. That's why Eduardo's proof by contradiction will turn out to fail. So we've got it. D is the answer. All right, let's move on to number 5. Use the proof to answer the question below. Given segment AB is congruent to segment BC. Okay, never hesitate to mark what it tells you right in your diagram immediately. Also says that D is the midpoint, interesting, of segment AC. That means that this is exactly halfway in here. What that tells us is that these segments are congruent. So now we've got some knowledge here. And it says prove triangle ABD is congruent to triangle CBD. Well, we already got two sides congruent. And also, if you notice, BD is shared between the two. So BD is congruent to itself. So with these three things, we already know why these two triangles are congruent. So let's read the proof. Statement. Segment AB is congruent to segment BC, and D is the midpoint of segment AC. That's given. Okay. Segment AD is congruent to segment CD. That's the definition of midpoint. That's why we were able to make these marks right here. Segment BD is congruent to itself, segment BD. That's called the reflexive property. So basically, we just stated what we'd already drawn into the diagram. So triangle ABD has to be congruent to triangle CBD. Why? Well, let's look at the diagram again. We have 1, 2, 3 congruent sides. So that's side, side, side congruence. Okay? So we knew that all along. We just looked for it. A, no. B, no. C, no. It's definitely D, side, side, side. Okay, and that's it for problem 5. Moving on to 6. In the figure below, AB is greater than BC. So AB is greater than BC. So this one will be greater, and this one will be less. Just a quick way to keep that in mind. If we assume that measure of angle A equals measure of angle C, so that would mean that the angles are congruent. It follows that AB equals BC. That's true, because if this angle is congruent to this angle, then these sides would have to be congruent. It would be an isosceles triangle. This contradicts the given statement that AB is greater than BC. That's right. This one is greater than this one, so they are not congruent. So this is a false statement that they are congruent. What conclusion can be drawn? Well, if we know that the sides cannot be congruent, then we know that these angles also cannot be congruent. So the measure of angle A cannot be the same as the measure of angle C. And where do we see that? Measure of angle A equals measure of angle B. No, measure of angle A is not equal to measure of angle B. Measure of angle A equals measure of angle C, or measure of angle A is not equal to measure of angle C. We can conclude that measure of angle A cannot be equal to measure of angle C, because if the sides are not congruent, then the angles cannot be congruent either. And that's it for number 6. Moving on to number 7. Use the proof to answer the question below. Given angle 2 is congruent to angle 3, again we mark these things immediately. We want to prove that angle 1 is congruent to angle 4. So let's check this out. These are alternate interior angles. If the alternate interior angles are congruent, then the lines are parallel. If the lines are parallel, then 1 and 4, the alternate exterior angles, will also be congruent. So we already know this, so now we're just going to work through how to write it. So, angle 2 is congruent to angle 3, given. Angle 1 is congruent to angle 2. Well, how do we know this? They're vertical angles, exactly. Vertical angles. And angle 3 is congruent to angle 4. Again, vertical angles. So, that's what's missing. Well, that's pretty simple. They're vertical angles. So we're going to say something about vertical angles. Complements of congruent angles are congruent, not relevant. Vertical angles are congruent. That sounds right. Let's just check the others to see if there's something better. Supplements of congruent angles are congruent, not relevant. Corresponding angles are congruent, also not relevant considering the statement. The statement says 1 and 2. 1 and 2 are congruent because they're vertical angles. 3 and 4 are congruent because they're vertical angles. Therefore, vertical angles are congruent is our answer. B. Okay, that does it for standard 2. And that was the proofs. So, not too bad. Hopefully you got it. Hopefully you rewind if you're having any trouble with anything. And leave a comment. I'll be checking. I'll get back to you if you have any questions. Thanks. Bye. Hi everybody and welcome. We're going to be doing standard 3 today. Let's take a look. Sorry, this one right here. Standard 3. Students construct and judge the validity of a logical argument and give counterexamples to disprove a statement. So standard 3 is problems 8, 9, 10, 11, and 12 in the STAR packet. So let's look at problem 8. Problem 8 says 2 lines in a plane always intersect in exactly 1 point. Well, we can imagine that any flat surface is a plane, so let's say that this paper is a plane. Here's 1 line. Now, it goes indefinitely, so any other line that goes a different direction will eventually cross it in some point. But it's possible to have another line that runs next to it. And of course, this relationship, as you can see, is that they are parallel. So this is the counterexample, because this is the only example where 2 lines in the same plane will never intersect. So that is number 8. Number 9. Which figure can serve as a counterexample to the conjecture below? So again, it's a counterexample, an example that proves the conjecture is false. If one pair of opposite sides of a quadrilateral is parallel, then the quadrilateral is a parallelogram. Well, let's start by making parallel sides. These ones are parallel. Now, and I'll mark them parallel. These are parallel sides. Now, if this side here and this side here are not parallel, then it's not a parallelogram. A parallelogram, all 4 sides would be opposite, or would be parallel to their opposite side. So what we have here is a rectangle, definitely not. Is a rhombus, definitely not. Is a square, definitely not. Is a trapezoid? Yes, it's a trapezoid. So that's your answer. It's a trapezoid because 1 pair of sides is parallel. Number 10. TRAP is an isosceles trapezoid with diagonals RP and TA. Which of the following must be true? Okay, a problem like this, you definitely need to draw something. So an isosceles trapezoid, here's what we know about isosceles trapezoids. The bases are parallel and the legs are congruent. And it says that TRAP are the vertices. And then the diagonals are RP, so this is diagonal RP, and diagonal TA. Okay, so what must be true? Well, let's think about this. These two diagonals are definitely congruent. So RP is going to be congruent to TA, but I don't think that I don't think they cut each other in half equally. I think that this section is longer than this section. Let's see what the questions are. RP is perpendicular to TA. No, that's not a 90-degree angle. No way. RP is parallel to TA. That's actually impossible because they intersect, so they can't be parallel. RP is congruent to TA. I think that's what we just said. I'm going to mark that. I think that makes sense. RP bisects TA. They're not cutting each other in half, because if they were, then this segment would be the same length as this segment. So they don't bisect each other. The only thing that is clear is that the two diagonals are congruent. Therefore, C is your answer. All right, number 11. Your conditional statement is shown below. If a quadrilateral has perpendicular diagonals, so perpendicular means 90-degree intersection, diagonals, then it is a rhombus. So what we want to find is one that has perpendicular diagonals that's not a rhombus. So this one here definitely has perpendicular diagonals. This one also has perpendicular diagonals. This one doesn't. So this one cannot be the answer. So we're looking for which one of these is not a rhombus. So rhombus, let's think about what a rhombus is. It's 4 congruent sides. So does this one have 4 congruent sides? No. So I think that might be the answer. I'll just put a little mark to show that that might be the answer. Does this one have 4 congruent sides? It sure looks like it. That's a rhombus, so that can't be the answer. And this one, I know it's kind of a trick. You think, well, that's a square, it's not a rhombus, but here's the thing. It has 4 congruent sides, so even though it is a square, it's also a rhombus. So, a square is a special kind of rhombus. So it still is a rhombus, leaving A as the only one that does have perpendicular diagonals, but is not a rhombus. It is, in fact, a kite. Okay, next, number 12. Students in a class rewrote theorems in their own words. One student wrote the following statement. The area of a parallelogram is the product of any base and any height. So basically they're saying B times H. But the key words here is any and any. We're going to find that it's not always true. So we're going to look for a counterexample to prove the statement is false. So sure, parallelogram is base times height, but there's a key relationship the base and height must have, and it's this. The base must be perpendicular to the height. If the base is not perpendicular to the height, then it can't count. So in this case, here's the base, here's the height, they're perpendicular. So A does fit the theorem, therefore A cannot be our answer, because again, we're looking for a counterexample. So A cannot be our answer. In B, they've assigned a different base and height, but if you look, they're still perpendicular. They still have a 90-degree intersection. Therefore, B fits the theorem and cannot be our answer. C, we have the base up here now and the height here. But again, if these are parallel and this is perpendicular, then this is also perpendicular. Therefore, this fits the theorem and cannot be our answer. D, now D is a little different. Here's the base and here's the height. They are not perpendicular to each other. So this is the one that is the counterexample. If you're calling this the base and this is the height, then that is not going to get you a base times height formula for the area of this parallelogram. So D is your counterexample. And that's it for Standard 3. Thank you very much, and tune in for Standard 4. Bye. All right, welcome everybody to Standard 4. We're going to be working on Standard 4. All right, funny start. Standard 4, students prove basic theorems involving congruence and similarity. As you can see here, Standard 4 is a big one. It goes all the way from problem 13 to problem 20. So the best way to approach this, let's come up with some of our theorems. Congruence can be proven by side, 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 angle, side, angle, side, angle, 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 side, and everyone's favorite, hypotenuse leg. That is 5 different ways to prove congruence. Similarity can only be proven 3 different ways. That's side, 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 where all 3 sides are proportional. That is angle, angle, where the 2 angles are congruent. And there is side, angle, side, where there are 2 proportional sides with a congruent angle included between them. So we'll start with number 13. Which triangles must be similar? So the word similar tells us we're looking for side, 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 angle, angle, or side, angle, side. So two obtuse triangles. Well, it says obtuse. This one's kind of obvious. It can't be the answer because, you know, if this angle is 130 degrees and this one's 100 degrees, they have nothing in common. So that's definitely not enough to prove similarity. Two scalene triangles with congruent bases. Scalene just means three different side lengths. So this one could be scalene, and this one could be scalene. And even if these two bases are congruent, it's certainly not enough to prove similarity. Here are two right triangles. Well, this is a right triangle, and this is a right triangle. Certainly not enough to prove similarity. Two isosceles triangles with congruent vertex angles. Well, now that's interesting. That's saying this isosceles one where this side is congruent to this, and this isosceles one where this side is congruent to this. If their angles are congruent, then what we've got is side, angle, side similarity. Bam. So that's got to be your answer, D. Okay. Which of the following facts would be sufficient to prove the triangle ABC and triangle DBE are similar? So here's ABC, here's DBE. What we need to notice is that they contain the same angle. Angle ABC is in both triangles, therefore we already have one angle. So we're probably looking for side, or angle, because we're given one angle. So let's see here. If CE and BE are congruent. Well, if these were congruent, would that have anything to do with these sides? No. It really wouldn't do much of anything. So that doesn't prove anything. If angle ACE is a right angle, well, that's also not enough because we don't know anything about this angle, so it wouldn't give us anything. So that's also not a good answer. If side AC and side DE are parallel, so this is interesting because we got to look at this. If these were parallel, then this would be a transversal. And if this was a transversal, then these would be corresponding angles. If corresponding angles are congruent, then what we have is one congruent angle, another congruent angle, angle similarity. That looks like it's going to do it. Let's just evaluate D to see what D has to offer. Angle A and angle B are congruent. Well, that's weirder because this angle again only belongs to one triangle, so it has nothing to do with the smaller triangle, so it doesn't prove anything. The answer has to be C because it's the only one that can prove similarity. And that's 14. Alright, let's look at 15. 15. Parallelogram ABCD is shown below. Which pair of triangles can be established to be congruent to prove that angle DAB is congruent to angle BCD? So let's try to see what it's really saying. It's trying to say that DAB is congruent to BCD. So DAB is this triangle here, and BCD is this triangle here. So if we're talking about the angles, DAB would be this angle, BCD would be this angle. So I think we've already kind of answered our question. If this triangle was congruent to this triangle, this angle would be congruent to this angle. The reason for that is that corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. So triangle ADC, let's look at this. ADC, that doesn't contain the angles that we're talking about, so that's not going to work. Triangle AED, AED again doesn't contain this angle, so that can't be what we're trying to prove. Triangle DAB, now that looks promising. Here's DAB is congruent to triangle BCD. We'll see if these two triangles, right here and right here, are congruent, then these angles have to be congruent again because corresponding parts of congruent triangles are congruent. So it's going to be C. And to evaluate D, triangle DEC again doesn't contain either of the angles we're looking for, so that can't be the answer. Alright, number 16. If triangle ABC and XYZ are two triangles such that AB over XY equals BC over YZ, which of the following would be sufficient to prove that they are similar? Well, let's take a look here. ABC and XYZ. It's always a good idea to start drawing. ABC, XY, Z. So I'm going to make little marks to say that AB corresponds to XY and that BC corresponds to YZ. We're not saying they're similar or that they're congruent. We're saying that they're proportional. But if we go back to our similarities, similarity, if you're given two proportional sides, what you're looking for is an angle. And specifically, we're looking for the angle between them. So if I have this angle congruent to this angle, what I have is side, angle, side similarity. So angle B congruent to angle Y will be our answer. Okay, number 17. In parallelogram FGHI, diagonals IG and FH are drawn and intersect at point M. So let's see, FGHI, and I always say draw everything. FGHI, the diagonals intersect at point M. Which of the following statements must be true? So FGI must be an obtuse triangle. FGI, not necessarily. The way I drew it, it looks obtuse, but if F could have been this way. It does not need to be obtuse. Triangle HIG. HIG must be an acute triangle. Well, as you can tell right here, my version is obtuse, so that cannot be the case. Triangle FMG. FMG must be congruent to triangle HMG. That's also unlikely. FMG does not need to be congruent to HMG, as this side does not need to be congruent to this side. That is not the case. Triangle GMH. GMH must be congruent to triangle IMF. That is true because opposite sides are congruent. Diagonals bisect each other. Therefore, by side, 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 we have congruent triangles. So D is going to be our answer. Again, opposite sides are congruent. Diagonals bisect each other. Therefore, by side, 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 these two triangles, GMH and IMF, must be congruent. So that's D. Okay, which of the following best describe the triangles shown below? Alright, so this one, we're going to see some things, but we're going to add some things as well. After all, this is 90, this is 60, this is 8. So that would mean that this angle up here has to be 30 degrees. And this is a 30, 60, 90, so we can use our 30, 60, 90 rules. If this is 8, this has to be 4, and this has to be 4 square root of 3. And now let's look at this one. If this is 30 and this is 90, then this one has to be 60. After all, that's just triangle sum theorem. Then if this is 8, this is 4, and this is also 4 square root of 3. So clearly these two triangles are completely congruent. You can go side, side, side. You can do pretty much any proof. They're congruent through and through. So, are they both similar and congruent? I think that's acceptable. After all, they're similar by angle, so that works. Similar but not congruent doesn't make any sense because they're definitely congruent. Congruent but not similar, that's just not possible. If they're congruent, they are inherently similar. And neither similar nor congruent, obviously nonsense. The only answer that makes any sense here is A. Okay, number 19. Which of the following statements must be true if triangle GHI is similar to triangle JKL? Well, think about this. If they are similar, then corresponding angles have to be congruent, and corresponding sides have to be proportional. So there's a lot you can tell, and it's nice to add the stuff in. So the two triangles must be scalene. That is not true. They could be equilateral. They could be isosceles. The triangles must have exactly one acute angle. That's not even possible. Every triangle has at least two acute angles, so that's nonsense. C. At least one of the sides of the two triangles must be parallel. Also pretty much nonsense. The relationship between the two triangles is irrelevant, and the idea of them being parallel is also irrelevant. The corresponding sides of the two triangles must be proportional. Well, that's pretty obvious. That's what we have right here. In other words, GH is proportional to JK, as GI is proportional to JL, as HI is proportional to KL. That's definitely the answer. Last, which method listed below could not be used to prove that the two triangles are congruent? Prove that all three sets of corresponding sides are congruent. Well, that's another way of saying side, side, side. So that can be. We're looking for things that could not be. Prove all three sets of corresponding angles are congruent. Well, there is no angle, angle, angle congruence proof. Angle, angle is enough for similarity, but without a side, you can't tell if they're the same size. You can only tell if they're the same shape. So I'm betting on this one. Prove that two sides and an included angle of one triangle are congruent to two sides and an included angle of the other triangle. Well, that sounds like this: side, angle, side. There is a side, angle, side proof, so that cannot be the answer. And prove that two angles and an included side of one triangle are congruent to two angles and an included side of the other triangle. Well, that's angle, side, angle. There's also an angle, side, angle proof. So the only one that is not a known triangle proof is angle, angle, angle. So that has to be the answer. And there you have it. There's standard 4. Probably one of the more tedious standards. You really got to pay attention to all your relationships and stuff. But rewind if you need to. Good luck with it, and I'll see you in standard 5. Thanks. Hi, and welcome. Today we're going to be working on standard 5, which is about triangle congruence and similarity. Let's take a look at it. Standard 5. Students prove that triangles are congruent or similar, and they're able to use the concept in corresponding parts of congruent triangles. Okay, standard 5, as you can see, is going to be problems 21, 22, and 23, right there, standard 5. Okay, so let's look at problem 21. In the figure below, AC is congruent to DF, so let's mark that. And angle A is congruent to angle D. So let's mark that too. The question says, which additional information would be enough to prove the triangle ABC is congruent to triangle DEF? Well, let's think about congruence. We can have side, 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 angle, side, angle, angle, side, angle, side, angle, or hypotenuse, leg. Given that what we have is an angle and a side, it looks like we're either going to have angle, angle, side, angle, or maybe side, angle, side. So let's look what our choices are. It says AB is congruent to DE. Well, if AB was congruent to DE, would that give us side, angle, side? Side, angle, side? It looks like it would. So you know what? I think that's enough to prove that the triangles are congruent. Let's just take a look at a few of the others. AB is congruent to BC. Totally irrelevant. Not even talking about two different triangles. BC is congruent to EF. Here's BC. Here's EF. That would be angle side side, and angle side side, as we know, is no good. And last, BC to DE. Here's BC. Here's DE. They're not corresponding. So again, AB is congruent to DE. Why? Because it gives us side, angle, side congruence. And that's 21. 22. Given AB and CD intersect at point E, angle 1 is congruent to angle 2. Alright, what we know is that these angles here have to be congruent because they're vertical angles. And then it tells us that 1 is congruent to 2. So, with those facts in place, we already know that we have two angles congruent. And it's asking us, can we prove that they're similar? It's very simple. Two angles congruent. Angle, angle, they are similar. That's the end of the problem. Very easy. 23, a little harder. Given E is the midpoint of CD, and C is congruent to D. So let's see. C is congruent to D, and E is the midpoint. If it's the midpoint, it means it cuts this segment exactly in half, which means that this is going to be congruent to this. So this is known information. So on top of that, we have the 90-degree angle here, 90-degree angle here. So what we've got is angle, side, angle congruence. That means that these two triangles are congruent. So what must be true? Well, angle A is congruent to angle D. Let's see. Angle A is congruent to angle D. They are not corresponding, so that's not true. Angle B is congruent to angle C. Again, not corresponding, so not true. So those are not true answers. CE is congruent to BE. Again, not corresponding, so not true. Last, AC is congruent to BD. That seems to be true. What we've got there is corresponding parts. And remember, corresponding parts of congruent triangles are congruent. C, P, C, T, C. Corresponding parts of congruent triangles are congruent. Therefore, D is our answer. And that's it for Standard 5. Thanks a lot. Hi everybody, and welcome to Standard 7. Standard 7 is about parallel lines cut by transversal, properties of quadrilaterals, and properties of circles. So let's take a look at it. Here's Standard 7. Students prove and use theorems involving the properties of parallel lines cut by a transversal, the properties of quadrilaterals, and the properties of circles. And let's see here. Standard 7 is going to be demonstrated in problems 26 through 32. So let's look at problems 26 through 32 in your packet. We'll start with 26. In the accompanying diagram, parallel line L and M are cut by transversal T. Okay, so that tells us that L is parallel to M. So I'm going to make little parallel marks just to make it a little more solid. Okay, which statement about angles 1 and 2 must be true? Let's think about this. Angle 1 here has a corresponding angle that is congruent to it, and it's this angle here. So these two angles are congruent. In the same way, angle 2 has a corresponding angle which must be congruent to it. So if you think about this, angle 1 and this angle are a linear pair, just as angle 2 and this angle are a linear pair. And that means that they're supplementary. So if this angle and this angle are congruent, I can say that angle 1 is the same as this one. Therefore, angle 1 is supplementary to angle 2. And, of course, angle 2 is supplementary to angle 1. So which statement about angles 1 and 2 must be true? That they are congruent? No, they're not congruent, or they're probably not congruent. That they're complements. Complements means they add to 90 degrees, so that's also not true. Supplement, that means they add to 180. That is the key word. That's what we're looking for, supplementary. And that they're right angles, they're probably not right angles, so that's not your answer. So it's definitely C. All right, let's look at B. What values of A and B make quadrilateral MNOP a parallelogram? Okay, one of the things we need to think about parallelograms is that opposite sides are congruent. So this is a little bit of a mathy one. It's kind of clever. We know that this side has to be congruent to this side, and this side has to be congruent to this side. So we're going to write two separate equations. We get 3A minus 2B equals 13, and we get 4A plus B equals 21. So those of you who've ever solved a multivariable system by substitution, that's what we're about to do. We need to combine these to eliminate the B. So what I'm going to do is I'm going to multiply this one by 2. So I'm going to get 8A plus 2B equals 42. Then I'm going to add this equation to this equation to solve for A. Watch what happens. 3A plus 8A is 11A. 2B plus negative 2B equals 0. And 13 plus 42 equals 55. Therefore, if 11A equals 55, then A has to equal 5. If A equals 5, we can plug that back in. Let's plug it into this one. 3 times 5 is 15. So 15 minus 2B equals 13. Therefore, B has to equal 1. So A equals 5, B equals 1. That is B. Okay. Number 28. Quadrilateral ABCD is a parallelogram. If adjacent angles are congruent, which of the statements must be true? So let's think about this. It's a parallelogram. So parallelograms, this has to be parallel. This has to be parallel. And then it says adjacent angles are congruent. So that means this angle has to be congruent to this angle. So if this angle is congruent to this angle, and this angle is congruent to this angle, and this angle is congruent to this angle, then they're all congruent. If they're all congruent, then they have to all be 90, because after all quadrilaterals add up to 360. So if they're all 90, now let's think a little bit about this. If they're all 90, what kind of figure does this actually have to be? A square? Well, not necessarily, because this side doesn't necessarily have to be the same as this. So square is probably not the right answer. A rhombus, it didn't say anything about all four sides being congruent, so it's not a rhombus. A rectangle, well, there we go. 4 right angles. I think it's a rectangle. Isosceles trapezoid, definitely not. It's not any kind of trapezoid. In fact, of these 4 choices, trapezoid is the only one that is not a type of parallelogram, so that was automatically out. Okay, moving on to number 29. 29. Here it is. Ha ha ha. Okay. For the quadrilateral shown below, what is measure of angle A plus measure of angle C? So again, we need to know quadrilateral. That means it adds to 360. We know that right away. So we know this, but we don't know this. All it's asking us to find is the sum of these two. So basically, all we got to do is isolate them. So 95 plus 32 is 127. And we know that the whole thing has to add up to 360. So 360 minus 127 is 233. We don't have to figure out what A and C is. All we got to do is figure out what the sum is. So we've already got our answer. It's D. It's actually a pretty simple problem. Okay, number 30. If ABCD is a parallelogram, what is the length of segment BD? Okay, here's one fact about parallelograms that not everybody knows. Diagonals bisect each other. And what that means is that this diagonal cuts this diagonal exactly in half. Therefore, if this part is 5, this part has to be exactly the same. And if this part is 6, then this part has to be exactly the same too. So BD is going to be 10, which is what it's asking. So BD is 10. Why? Because in parallelograms, diagonals bisect each other. Good thing to know. Okay, number 31. The diameter of a circle is 12 meters. If point P is in the same plane as the circle and 6 meters from the center of the circle, which best describes the location of P? So I like to always draw it. So it says the diameter is 12 and that P is 6 from the center. Well, if the diameter is 12, then the radius is 6, right? And the radius, any one of these can be a radius because the radius is the distance from the center to the edge. So if P is 6 from the center, anywhere on this plane, it's always going to end up exactly on the edge of the circle. So any one of these points could be P, but P will always be on the edge of the circle. So let's read our choices. Point P must be on the circle. On the circle is another way of saying on the edge of the circle. So I'm going to go with this is probably my answer, but I'll keep reading just to see if something better shows up. Point P must be inside the circle. No, inside the circle. Anything less than 6 would be inside the circle. So that cannot be the answer because P is exactly 6 from the center. Point P may be either inside or outside the circle or on the circle. No, that's just not true. Point P can only be on the edge of the circle, so it cannot be C. Point P may be either inside the circle or on the circle. It can't be inside because it's exactly 6 from the center. And again, any distance that's 6 away from the center is on the edge because 6 is the radius. So the only answer that makes sense is A. Point P must be on the circle. And there you have it. Okay, last one. Number 32. Given P is parallel to Q. Let's mark them parallel. So they're parallel. And M is parallel to N. So these are also parallel. Okay. And the measure of angle 1 equals 75. So let's write this right away. It says find the measure of angle 2. Well, if we have parallel lines, then we can do some stuff pretty quick. Let's mark corresponding angles congruent. Therefore, this one here is 75. And then with linear pairs, let's do this one. This one will be 105. Okay, that was pretty quick. We went corresponding angles and linear pairs. Now look at the relationship we have here. We have the 105 here, and we have 2 here. These are also corresponding angles. Corresponding angles have to be congruent. Therefore, 2 has to be congruent to this angle. Measure of angle 2 is 105 degrees. That is D. And that's it. That's it for Standard 7. I know those problems went pretty quick. Make sure to rewind if you're having trouble understanding anything. Thanks a lot. See you next time. Hi, and welcome to Standard 8. We're going to be working with problems with perimeter, circumference, surface area, and volume of common geometric figures. Let's take a look at Standard 8. Standard 8 says, students, know, derive, and solve problems including perimeter, circumference, area, volume, lateral area, and surface area of common geometric figures. Okay, Standard 8 is represented by problems starting with 33 on to 37. So from 33 to 37. So let's look at problem 33. A right circular cone has a radius of 5 inches and a height of 8 inches. Okay, key thing it told us was the word right. So that tells us this right away. And I see this variable L here. Anyone know what to do? That's right, Pythagorean theorem. So 5 squared plus 8 squared equals L squared. That's 25 plus 64 equals L squared. That's 89 equals L squared. Therefore, L equals the square root of 89. Okay, we did that before we even read the rest of the problem, because I was pretty sure we were going to have to solve it. Let's see what it actually says. What is the lateral area of the cone? Ooh, maybe not a familiar concept, but not difficult, because it gives you the formula right here. Lateral area of the cone equals pi times the radius times L, where L is the slant height. So we just solved L. So what we've got is pi times the radius times square root of 89. So what's the radius here? Well, the radius is right there. So it's 5 pi square root of 89. Maybe not in that order, but that's the answer we're looking for. So which one looks like that? That would be D. 5 pi square root of the 89 square inches. Easy. Okay. Figure 34, it says figure ABCD is a kite. And it says what is the area of figure ABCD in square centimeters. So we can do this as 4 different triangles if we want. So 6 times 8 is 48, and because it's a triangle we divide by 2, so this is 24. This one's also 24. 8 times 15 is 120. 120 divided by 2 is 60, and this is also 60, so you can add these together. 60 plus 60 is 120, 144, 168. So 168 is our answer. The other way to do it is you can actually use the kite formula, which is going to be diagonal 1 times diagonal 2 divided by 2. That works just as well. This diagonal here has a length of 16. This has a length of 21. So 16 times 21 is 336. 336 divided by 2, because remember, divide by 2. So 336 divided by 2, 2 goes into 3 one time, that makes 2. 2 goes into 13 6 times, that makes 12. 2 goes into 16 8 times. Either way, we get 168 for our answer. So 168 is the area of this kite. Okay, next one, number 35. If a cylindrical barrel measures 22 inches in diameter, how many inches will it roll in 8 revolutions along a smooth surface? Okay, so we've got our cylindrical barrel. That means it makes a cylinder. And the diameter is 22 inches. Okay, so if it's rolling like this. Basically, every time it rolls 1 full revolution, that's equal to 1 times the circumference. So if we knew the circumference, we'd know how far it rolls in 1 revolution. And the circumference is just the diameter times pi. So circumference equals 22 pi. And how many revolutions? 8 revolutions. That means 22 pi times 8. So 22 times 8 is 176. Don't forget the pi, especially on Thanksgiving. Don't forget the pi, because we're talking about the circumference, not the diameter. Circumference, not diameter. Therefore, C is your best answer. Okay, next. Ooh, this one's caused a few people some headaches. A sewing club is making a quilt. Okay, quilt. It's important to know what a quilt is. A quilt is like a blanket that's made of small little patches. Okay? So this one is made of 25 squares on each side, with each side of the square measuring 30 centimeters. If the quilt has 5 rows and 5 columns, what is the perimeter of the quilt? So we kind of do this. So this gives us our quilt. See, it's 5, 1, 2, 3, 4, 5 by 5. 1, 2, 3, 4, 5. And each side of each of these squares is 30. So if that's 30, then this distance will be 150. And the question is, what is the perimeter? So it's 150 here, that means 150 here, 150 here, and 150 here. So 4 times 150, therefore the answer is 600 centimeters. Okay. Basically, I think the word quilt is the most confusing part of that problem. And last one, we've got the minute hand of a clock is 5 inches long. What is the area of the circle in square inches created as the hand sweeps an hour? So that's when you just kind of got to visualize. Say this is the minute hand. It's 5 inches long. If it sweeps an hour, that means it goes all the way around the circle. So basically, it's asking us what is the area of this circle. So that's going to be pi times the radius squared. If the radius is 5, it's going to be 25 pi units squared. And the best answer is C. And that's it for Standard 8. Hopefully it wasn't too tough. Make sure to rewind if there's things you don't understand. And I'll see you next time. Hi, and welcome to Standard 9. Standard 9 is about areas, surface areas, and volumes of complex forms. Let's take a look at it. Standard 9 says, students compute the volumes and surface areas of prisms, pyramids, and cylinders, cones, and spheres. The student commit to memory the formulas for prisms, pyramids, and cylinders. Now we'll look at this one here. 38, it says the four sides of the figure will be folded up and taped to make an open box. So if you look at this, if you were to take this and fold it right here, what you would get is a freestanding box. The base would be the size of this square here, and the height would be the height that you get by folding this upwards. So the base is going to be 5 times 5, or 25, and the height will be this distance here, which is 2. So what we basically got is a box that looks like this. This is 2, this is 5, this is 5. So 5 times 5 is 25, times 2 is 50. 50 cm cubed. 50 centimeters cubed will be the volume. So A is your answer. Okay. Number 39. A classroom globe has a diameter of 18 inches. Okay, that tells us that this distance is 18 inches. So let's make sure to mark that correctly. Which of the following is the approximate surface area in square inches of the globe? Okay, so luckily it totally gives us the formula. So it's 4 pi times the radius squared. Now remember, this is not the radius. The radius, if the diameter is 18, the radius equals 9. So if r equals 9, then it's 4 pi times 9 squared. Now 9 squared equals 81, so it's 4 pi times 81. So 4 times 81 is 324 times pi. And pi is 3.14. So what we got is 324 times 314 for our answer. And there's a decimal there. So 4 times 4 is 16, 4 times 2 is 9, 4 times 3 is 12, 0, 4, 2, 3, 0, 0, 2, 7, 9. So 6, 3, 1, 7, 12. So what we've got here is 1017.4. It's really the only reasonable answer. My answer wasn't exactly the same, but it's the only answer that fits what we've got here. So that's got to be the answer. Let's see. Number 40 is the last one we're going to do. Ooh, another fun pi problem. Vic is constructing a spherical. Okay, spherical again means a sphere. So that's a circular globe type thing. Model of Earth for a science fair project. His model has a radius of 24 inches. Radius. Okay, since roughly 75% of Earth's surface is covered by water, he wanted to paint 75% blue to illustrate this fact. Approximately how many square inches of his model will be painted blue? Well, the first thing we've got to do is figure out the surface area. So the surface area is 4 pi times the radius squared. So 24 squared times 4 pi. So 24 squared is 576. So that times 4 is going to be 2,304. So then 2,304 times pi, 2,304 times 3.14, and this is going to be a big number. Going by the answers we have here, I think it's safe to estimate because these answers are not close to each other. So if we just estimate this, let's say it's 300 times 2,500, it's going to be, or 3 times 2,500, it's going to be about 7,500. Okay, when you see that, you're probably leaning towards answer B. But remember, we've got to do 75%. 75% is 3/4. So if we do 3/4 of 7,500, it's going to be smaller than 7,500. 3 times 7,500 is, if my calculations serve me correctly, 22,500. And when you divide that by 4, you're going to get 5,000 something. The only answer that's even close to fitting this is A. Now you could do your math a lot more accurately, but considering, and this is a good thing to learn, considering the difference between these answers, you only need a ballpark answer because only one of these is going to be close. So it's something to think about. And that's it for Standard 9. Thanks a lot. Hi, and welcome to Standard 10. We're going to be doing areas and perimeters of complex polygons. So take a look here. Standard 10. Students compute the areas of polygons, including rectangles, scalene triangles, equilateral triangles, rhombi, parallelograms, and trapezoids. Boy, that's a mouthful. The problems associated in your packet with Standard 10 would be problems 41 through 47. So we're going to start at 41. As you can see, we kind of had an aborted attempt. So we're starting over, but let's take a look at it. The rectangle shown below has length 20 and width 10. Okay? Now, if 4 triangles are removed from the rectangle as shown, what will be the area of the remaining figure? So what we're going to do is we're going to take the area of the rectangle. Well, if it's 20 times 10, then that's going to be 200. And the 4 triangles. This one here is 4 by 4, so 4 times 4 is 16, divided by 2 is 8. There are 4 of them, so 4 times 8 is 32. So basically, the big rectangle minus the 4 triangles is 200 minus 32. 200 minus 32 is 168, therefore C is our answer. Okay, number 42. If RSTW is a rhombus, it tells us it's a rhombus. As soon as we see that word, we should know that all 4 sides are congruent. So therefore, all of this is true. What is the area of triangle WXT? So here's WXT. So this is interesting. One thing you got to remember about a rhombus is that the diagonals are perpendicular. Therefore, this is 90. If you think about this, if this is 90 and this is 60, then this has got to be 30. And if this is the hypotenuse, and the hypotenuse is 12, then A has got to be exactly half of that, because in the 30, 60, 90, C equals 2A. Therefore, this is 6, and then B is A times the square root of 3, so it's 6 square root of 3. So if we're finding the area of this triangle, it's going to be 6 times 6 square root of 3 divided by 2. So that's 6 times 6 square root of 3 over 2. 6 times 6 square root of 3 is 36 square root of 3 over 2. So it equals 18 square root of 3. And that's our answer. The answer is A. Okay, number 43. What is the area in square units of the trapezoid shown below? Alright, so there's 2 ways to approach this. You can do this kind of the easy way, or you can do it the more sophisticated way. They're both easy in their own way. I like to look at anything on a coordinate plane as a bunch of triangles and rectangles. It's just easy and you don't have to remember many formulas. So if this is a rectangle, then the base is 8, the height is 5, therefore it is 40. And this triangle, the base is 4, the height is 5, so 4 times 5 is 20, divided by 2 is 10. 40 plus 10 is 50. So that will work. The other way of doing it is the trapezoid area formula. The base up here is 8, the base down here is 12, and the height is 5. So 8 plus 12 divided by 2 times 5. Well, 8 plus 12 is 20. 20 divided by 2 is 10, and 10 times 5 is 50. So 2 different methods both get us the same answer. The answer is definitely 50. Okay. Number 44. The figure below is a square with 4 congruent parallelograms inside. Okay, it's a square. So if it's a square, then all 4 of these sides have to be congruent. Therefore, if this is 12 and this is 12, then the area of the square has to equal 144. So that we know. It says, what is the area in square units of the shaded portion? So basically, we're cutting these 4 parallelograms out to find the shaded portion. Now this seems hard, but really all it is going to be the square minus 4 parallelograms. So we already know that the square is 144. So think about this. The parallelograms are all congruent. So if this is 3, this is also 3. And if this is 5, well, parallelogram area formula is base times height. So 3 times 5 is 15. If they're all congruent, then they're all 15. So basically, we're cutting out 4 15s. So it's 144 minus 4 times 15, which is 60. 144 minus 60 is 84. And that's our answer. The answer is B. All right, 45. What is the area in square meters of the trapezoid shown below? Okay, again, trapezoid is going to be base 1 plus base 2 divided by 2 times height. This one gets a little weird because the height's not given. Base 1 is going to be 12. Base 2 is going to be 6 divided by 2. Okay, but we've got to find the height. So this one is kind of designed to mess you up. But think about this. If this is 12 and this is 6, then this one is 6 longer. That means that this little piece is 3 and this little piece is 3. Does everybody get that? 3 plus 6 plus 3 equals 12. So if these are both 3, then we can use that to find this distance. Because after all, this is a right triangle. So 3 squared plus x squared equals 5 squared. 3 squared plus x squared equals 5 squared. Therefore 9 plus x squared equals 25. Therefore x squared equals 16. Therefore x equals 4. So we know now that the height is 4. So we've got base 1 plus base 2 divided by 2 times 4. 12 plus 6 is 18. 18 divided by 2 is 9. So it's 9 times 4, which equals 36. So it seems tough at first, but really not that bad. Okay, 46. What is the area in square inches of the triangle below? All right, this is an equilateral triangle. I don't know if anybody remembers s over 2 squared square root of 3. That will always get you the area of an equilateral triangle. In other words, 10 divided by 2 is 5. 5 squared is 25, so it's 25 square root of 3. If by chance you don't remember that, you can always remember this. An equilateral triangle is 60, 60, 60. So if it's 60, 60, 60, and you cut it in half, and this is 90, then this is 30. So this would be 5, this would be 10, and this would be 5 square root of 3. So if you know the height and you know the base, you can put it back together. 5 square root of 3 times 10 divided by 2. So that would be 50 square root of 3 over 2, which equals 25 square root of 3. And that gets you your area. Okay, one more problem. All right, what is the area in square centimeters of rhombus RSTV if RT equals 16, 16, and SV equals 12? Well, if this is 16, let's think about a couple of things. First of all, we know that this is 90 degrees. Second of all, we know that these bisect each other. So if this is 16, then this is 8 and 8, and this is 12 and 12. Funny. 6 and 6. So you could do it as 4 separate triangles. After all, 8 times 6 is 48, so that's 24. There's 4 of them, so 4 times 24 equals 96. So that will get you the answer. The other way of doing it is diagonal 1 times diagonal 2 divided by 2. So 16 times 12 over 2. 16 times 12 is 192. When you divide 192 divided by 2, that is, well, 2 goes into 1, 0 times goes into 19, 9 times. That makes 18. Subtract, you get 12. 2 goes into 12 6 times, 96. Either way you do it, you get 96. And that's it. And, that's it for Standard 10. Thanks a lot. See you next time. Hi, and welcome to Standard 11. This is about changes in dimension and how changes in dimension have effects on figures. Let's read it. Standard 11 says, students determine how changes in dimensions affect the perimeter, area, and volume of common geometric figures and solids. As you can see, Standard 11 is covered by only 2 problems, problems 48 and 49. So, here we go. Here's 48. 48 says, the perimeters of 2 squares are in a ratio of 4 to 9. What is the ratio between the areas of the 2 squares? So let's kind of think of this. The easiest way to make their perimeters have a ratio of 4 to 9 is make this one be all 4s and make this one be all 9s. After all, that would give us 16 over 36, which reduces to 4 over 9. So that's our perimeter over perimeter, reducing to 4 over 9. So if we've got that, then let's figure out what the areas are. The area of this will be 4 times 4, or 16. And this will be 9 times 9, or 81. So the ratio will be 16 over 81. There you have it. 16 over 81, that would be D. Okay, that's it for number 48. 49, Leah made 2 candles in the shape of right rectangular prisms. So they're going to be right rectangular prisms. So here's a right rectangular prism. Okay. The first candle is 15 high, 8 long, and 8 wide. The second candle is 5 centimeters higher. So 5 centimeters higher than 15 would be 20. And it will still be 8 and 8. And it says it's 5 centimeters higher, but it has the same length and width. How much additional wax was needed to make the taller candle? In other words, how much bigger is this one than this one? So the difference, the answer to this question will be this shaded block. So what we're going to do is we're going to find the volume of this one and the volume of this one, and we're going to subtract. So this one is 8 times 8 times 15. And this one is 8 times 8 times 20. Clearly, the other way we can do it is just do this part. So that would be 8 times 8 times the difference, which is 5. Anyway, let's do it this way first. It's 64 times 15, which is 960, and this one is 64 times 20, which is 1,280. So 1,280 minus 960 is 320. So that's the answer. The other way to do it is we just look at the part that we're talking about, the difference. Again, it's 8 times the difference, which is 5. 8 times 8 is 64 times 5. Well, 5 times 4 is 20. 5 times 6 is 30, plus 2 is 32, therefore 320. Either way, we get 320. Okay, I know that was going pretty fast. If you need to rewind, rewind. If you want to do the arithmetic yourself to check, please do. Thank you very much. Hi, and welcome to Standard 12. Standard 12 is about using interior and exterior angles to solve and classify side lengths and polygons. Let's read it. Standard 12. Students find and use measures of sides and of interior and exterior angles of triangles and polygons to classify figures and solve problems. So, Standard 12 will be problems 50 through 56. So let's look at problem 50. 2 angles of a triangle have measures of 55 and 65. Which of the following could not be a measure of an exterior angle of the triangle? So let's kind of draw a triangle. It says one will be 55, one will be 65. We can do the triangle sum theorem to find the third one. So if I add these two together, I get 120, which leaves 60. So the question is kind of tricky. It says which could not be a measure of an exterior angle? Well, the exterior angle to the 55 would be 125. The exterior to the 65 would be 115, and the exterior to the 60 would be 120. These are all linear pairs, so they add up to 180. That's how I find those. Okay, so which could not be? Well, 115, we've got it right there, so that can be. 120, we've got it right there, so that can be. And 125, we've got it right here, so that can be. Therefore, 130 has to be our answer by process of elimination. Okay, number 51, the sum of the interior angles of a polygon is the same as the sum of the exterior angles. What type of polygon is it? Okay, so good way to think of this. Well, we know that triangles are 180 interior. And we also know that exteriors are always 360. We know that quadrilaterals are 360. And like we said, exteriors are always 360. So it looks like quadrilateral is going to be our answer. Just check a pentagon. A pentagon, 5-sided figure, it's going to be 540 for the interiors and 360. So the question is, If the sum of the interiors is the same as the sum of the exteriors, what kind of polygon is it? The only place where that's true is in a four-sided figure or a quadrilateral. So our answer is A. Okay, so that was 51. On to 52. 52, here it is. Okay, 52 says find the measure of angle X. So what we have here is a triangle and then an exterior angle. So what we're going to do is we're going to find this angle and then use linear pairs to find this angle. So 25 plus 60 is 85. So we've got 180 minus 85 equals 95. But that's not the answer. That's the measure of this angle. Now if we look at X is a linear pair to this one, so it's got to be 180 minus 95 or 85. There is a theorem that says that when you want to find the exterior angle of the unknown angle in a triangle, you just take the sum of the other two angles. In other words, 60 plus 25 will always get you this angle, or 85. So here you go. C is your answer. Okay, on to 53. If the measure of an exterior angle of a regular polygon is 120, how many sides does the polygon have? Okay, so exterior and regular are key words here. Exterior tells us it's going to add up to 360. And it says regular, so they're all going to be equal. And if it adds up to 120, then what we're really doing here is dividing. If the exterior is 120, and we know it adds up to 360, then how many angles does it have? It has 3 angles. Therefore, how many sides does it have? It has 3 sides. It's a triangle. Equilateral triangle, actually. Okay, 54. In the figure below, AB is parallel to CD. What is the value of X? Okay, so saying that AB is parallel to CD. If these are parallel, then these are same side interior angles. Same side interior angles are supplementary. For that reason, these two angles have to add up to 180. So we can write this. X plus 40 plus X minus 40 equals 180. So we combine like terms, we get 2x, the 40s cancel out, we get 2x equals 180, therefore x equals 90. So we're trying to find the value of x. Well, we did it. It's 90. Number 55. The measures of the interior angles of a pentagon are 2x, 6x, 4x minus 6, 2x minus 16, and 6x plus 2. What is the measure in degrees of the largest angle? Well, first of all, the largest angle has got to be 6x plus 2. That's just the biggest side that we've got, or angle that we've got. So we know that it's a pentagon, so it has 5 sides. What you do is n minus 2 times 180. So 5 minus 2 is 3, and 3 times 180 is 540. So we know that all of these have to add up to 540. Therefore, 2x plus 6x plus 4x minus 6 plus 2x minus 16 plus 6x plus 2 equals 540. This one's kind of a big pain. Okay, so 2x plus 6x is 8x plus 4x is 12x plus 2x is 14x plus 6x is 20x. So we have 20x, and then we have negative 6 minus 16 is negative 22 plus 2 is minus 20. So there we go. 20x minus 20 equals 540. We'll add 20 to both sides. We get 20x equals 560. So then we divide by 20. And we get x equals 28. Now that's not the answer. It's not asking us to find x. It's asking us to find the measure of the largest angle. Well, the largest angle is equal to 6x plus 2. So what we do is 28 times 6, and then we're going to add 2. So this is 8, 48, 12, 16, 168 plus 2, 170 will be our angle measure. And our answer is C. Okay, 56. Last one in this standard. A regular polygon has 12 sides. What is the measure of each exterior angle? Well, keyword here is 12 and regular. Regular means all the angles will be the same, and exterior tells us again that it adds up to 360. So if it has 12 sides, it has 12 angles. So 360 divided by 12 is 30. So the answer is B. Okay, that about does it for Standard 12. Thank you very much. Please tune in for Standard 13. Hi, and welcome to Standard 13. Standard 13 is kind of a fun one. It's relationships between angles. Let's read it. Standard 13. Students prove relationships between angles and polygons by using properties of complementary, supplementary, vertical, and exterior angles. We see that Standard 13 will represent problems 57 to 59. So let's look at problem 57. It says, what is the measure of angle 1? So here's angle 1, and we want to know this. Let's see what we do know. We know that this angle here is 36. We know that this is 90. If these two angles have to add up to 90, then this one here would be 54. Also, we know that this one here is 88. We know that these are linear pairs, so that makes 92. And I think clearly if we're looking for 1, what we've got here is triangle sum theorem. So 54 plus 92 is 146. And 180, because that's the full triangle, minus 146 will get us our answer. It'll be 34 degrees. The answer is A, 34 degrees. Okay, number 58. What is the measure of angle WZX? So WZX is going to be this angle that we're asking about. All right, so let's see what we can figure out. We know this exterior angle is 132, and we know that these are a linear pair, so this one here has got to be 48. Now, if we look at this triangle, we've got a 52, we've got a 48, and we've got a question mark. Well, it's triangle, so triangle sum theorem might solve it. 48 plus 52 is a perfect 100. Therefore, 180 minus 100 is 80. And we've got this angle, and of course this angle should be the same because these are vertical angles. So the one we're trying to find, this one, has to be congruent. Therefore, it is 80. The answer is A, 80. 59. What is the measure of an exterior angle of a regular hexagon? Okay, so we're talking about exterior, we're talking about regular, we're talking about hexagon. Hexagon is 6-sided. So if it's regular, then they're all going to be the same, and exteriors have to add to 360. So if it's a hexagon, there's going to be 6 of them. Therefore, we're going to divide by 6. We're going to get 60, and that will be our answer. Okay, not bad. I know it was quick. Rewind if you need to, and please join us for Standard 14. Bye. Hi, and welcome to Standard 14. Standard 14 is interesting. We only do one thing. We prove the Pythagorean theorem. So let's read it. Standard 14, students prove the Pythagorean theorem. That's all it says. And Standard 14, as you can see, there's only one problem. Problem 60. Okay, let's look at it. This one is a bit complex. A diagram from a proof of the Pythagorean theorem is pictured below. So there it is. Which statement would not be used in the proof of the Pythagorean theorem? Alright, so it has 4 different statements. I think the best way to do it is to do the proof ourselves. So if I look at this, first thing I know is that the big square is equal to the small square plus the 4 triangles. Okay, you can see that? The big square is equal to the small square plus the 4 triangles. So now let's do a little math here. The side length of the big square is A plus B. So that's going to be A plus B squared. That's the big square. Is equal to the small square, whose side length is C. So that's going to be C squared plus the 4 triangles. And the triangles have one side that is A, one side that is B. Therefore, it's going to be 4 of them times AB over 2. The reason it's AB over 2 is because it's base times height divided by 2. Alright, so now we're going to FOIL this out. We've got A plus B squared. So A times A is A squared. A times B is AB plus A times B, which is AB again, plus B squared. And that's our FOIL. So A squared plus AB plus B squared is the area of the big square. And that's going to be equal to C squared plus, we'll do the distributive property here, 4AB over 2 is going to equal 2AB. Okay, so we've got A squared plus AB plus B squared equals C squared plus 2AB. Now notice here we've got AB plus AB. When we combine these two, we get another 2AB. So we can rewrite as a squared plus 2ab plus b squared equals c squared plus 2ab. And what you're going to notice is that if we have 2ab here and 2ab here, we can subtract it out, and the last thing it's going to give us is a squared plus b squared equals c squared, the proof of the Pythagorean theorem. So let's look at what our choices are. Do we need to know that the area of a triangle equals 1/2 AB? We certainly do, because we use it right there. So that can't be the answer, because we're looking for the thing that is not used. Do we need to know that the 4 right triangles are congruent? We certainly do, because we're multiplying by 4. If they weren't congruent, we would not be able to do that. Do we need to know that the area of the inner square is equal to half the area of the largest square? Well, it never exactly says that. It says that the area of the inner square plus the 4 triangles is equal to the area of the largest square, but it never says that this is half of this. So that sounds a little fishy. I'm going to hold that out there. And then D, the area of the largest square is equal to the sum of the areas of the smaller square and the 4 right triangles. Well, that is our starting statement. So that we definitely used. So the one we did not use, was C, which says the area of the inner square is equal to half the area of the largest square. We did not use that. Okay, that's standard 14. Go slow, rewind if you need to, and good luck with it. And I'll see you in standard 15. Thanks. Hi, and welcome to standard 15. Standard 15 is about using the Pythagorean theorem to solve. So let's see what it's about. Standard 15, students use the Pythagorean theorem to determine distance and find missing lengths of sides of right triangles. So standard 15 will be these 3 problems. That is problems 61, 62, and 63. So let's look at problem 61. It says a right triangle's hypotenuse has length 5. If one leg is length 2, what is the length of the other leg? So first of all, it's a right triangle. We know that. We also know that the hypotenuse is 5, and that one of the legs. So the other 2 legs are called. The other 2 sides are called legs. So this one will be 2, and the one we want to know is this one. So we'll call that x. So clearly, if it's a right triangle, this is a Pythagorean theorem problem. So what we've got is 2 squared plus x squared equals 5 squared. That's 4 plus x squared equals 25. We subtract 4 from both sides. We get x squared equals 21. We take the square root of both sides, and x is the square root of 21, which can't be broken down, so we keep it. Square root of 21. Okay, pretty simple, that one. This next one is kind of my least favorite problems. It's really difficult. A new pipeline is being constructed to reroute its oil flow around the exterior of a national wildlife preserve. The plan showing the old pipeline and the new route is shown below. Alright, so let's look at this. The new pipeline is the long way, and the old pipeline is the short way, but it is the hypotenuse. So what we have here is side A, side B, and side C. So it looks like it's going to ask us to find the length of the old pipeline. That'll be the C in the Pythagorean theorem. But it also says about how many extra miles, so here's this word extra miles, will the oil flow once the new route is established. So what it's really saying is this distance minus this distance. So what we've got to do is figure out what this is and then subtract it from the sum of these two. So 60, 32, and C. This one's difficult in a lot of ways. The numbers are just very big. One of my favorite ways to do it is to reduce the problem. After all, if I reduce this and just find a factor that I can reduce out, I can multiply my C by that factor and get my final answer. And what I see here is that these are both multiples of 4. So if I divide them by 4, what I get here is 8 and 15. Now remember, whatever I get for C, I have to multiply by 4 to get the right answer. But this is much easier to do. 8 squared plus 15 squared equals C squared. So that's 64 plus 225 equals C squared. So that's 64 plus 225 is 289 equals C squared. So I take the square root and I get 17 equals C squared. Now remember, I divided by 4, so I have to multiply by 4 to get my answer. So 17 times 4 is 68. And that means that this distance is 68 miles. So going back to the question, about how many extra miles will the oil flow once the new route is established. What you do is you take the old route, which is 68, and you look at the new route. Well, the new route is going to be 32 plus 60, which is 92. So you got 92, and how much extra will it flow? Well, 92 minus the old route of 68 gets us 24. So the answer is A, 24. It's a pretty tough problem. There's a lot of details to pay attention to. So be really careful with that one. All right, 63. I like this problem. It's not too tough, but it's clever. What is the height of this rectangle? So the height of the rectangle is this distance. So it's a rectangle. It tells us that. It uses the word rectangle. So that tells us that these are all 90-degree angles. And that's important because the fact that they're 90-degree angles means we can use the Pythagorean theorem to solve for the question mark. So it's going to be 7 squared plus question mark squared equals 8 squared. That's 49 plus question mark squared equals 64. So we subtract 49 and we get question mark equals square root of 15. So the answer is C. And that about does it for Standard 15. Thanks for following along. Make sure to rewind if you need to, and I'll see you in Standard 16. Thanks a lot. Bye. Okay. Welcome to Standard 18. Standard 18 is maybe a bit of a tough one. It's trigonometry. Let's read it. Standard 18. Students know the definitions of basic trigonometric functions defined by the angles of a right triangle. They also know and are able to use elementary relationships between them. For example, tangent of x equals sine of x divided by cosine of x. And sine squared plus cosine squared equals 1. Okay, that's a lot of words. Let's see what we're really in for. Standard 18 is every problem from 74 to 78. So let's look at problem 74. In the figure below, if sine of x equals 5 over 13, what are cosine of x and tangent of x? Well, here's x. And sine, remember, this whole thing functions on toa. So that is sine is opposite over adjacent, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. I think I just said opposite over adjacent. I meant opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay, so the sine is 5 over 13. That means the opposite over the hypotenuse is 5 over 13. So let's just put 5 for the opposite and 13 for the hypotenuse. Now, we're not given this one, but we can do the Pythagorean theorem to find it. So it's going to be 5 squared plus x squared equals 13 squared. It's 25 plus x squared equals 169. That is x squared equals 144. That's x equals 12. Okay, so we've got a 12 here. Now, this was the opposite. This was the hypotenuse, and this is the adjacent. So we need to find the cosine. So the cosine is going to be, again, adjacent over hypotenuse. So the cosine will be 12 over 13. And the tangent will be opposite over adjacent, or 5 over 12. So cosine equals 12 over 13. Tangent equals 5 over 12. A looks to be the answer. Let's just check the other ones. Cosine equals 12 over 13. But they get the tangent wrong. See, that's wrong. Cosine is 13 over 12. That's wrong. It's 12 over 13. And again, that's wrong. So the only one that fits is A. Okay, so that's it for number 74. 75. In the figure below, sine of A equals 0.7. Okay, so the sine of A is 0.7. Okay, and it says what is the length of AC? So AC is the one we want to know. So we'll call this X. So what we get here is that we're talking sine. So this is the opposite, this is the hypotenuse. So sine is opposite over hypotenuse. So in other words, what we have here is that 21 over x equals 0.7. So if we want to get x alone, well, the first thing we can do is multiply by x on both sides. And that'll disappear, and we get 0.7x equals 21. Then we can divide by 0.7. So by 0.7. So basically, that isolates the variable. We get x equals 21 over 0.7. So here's 21. Here's 0.7. Move that one. I'll turn that to 210. So 7 into 210. Well, 7 goes into 21 3 times. That makes 21. 21 minus 21 is 0. 7 goes into 0 0 times, but that gives us our answer. Our answer is 30. So x equals 30. All right, next one, 76. Okay. Approximately how many feet tall is the streetlight? All right, so here we're given 40 degrees. So that's our angle of record. We're giving our h. Now our h here, that stands for height, but that is not the hypotenuse. That is the opposite. And the 20 here is the adjacent. So opposite adjacent, really quick, we know this is a tangent problem. So here's what we're using. We're not going to be using cosine. We're not going to be using sine. So it's going to be h over 20 equals 0.84. So of course, if you want to get h alone, it's real simple. You just multiply both sides by 20. And that crosses out. You get h equals 0.84 times 20. So that's 0, 0, 0. This is going to be 816. And we move the decimal over twice, so we get 16.8 is our answer. Our answer is C. Okay, so that's number 76. Now we're going to do number 77. Right triangle ABC is pictured below. Which equation is correct for BC? Okay, so this one has a little bit of a trick to it. But if we're using this as our angle of record, then to find BC, you can say that BC, of course, is the opposite, and this is the hypotenuse, and this is the adjacent. So you can say that BC over AB is the tangent of, or sorry, is the sine of 32. Okay, so let's see, sine of 32, BC over AB. Let's see, this isn't AB. This represents AC, so that's not correct. The other one that says sine of 58. Okay, so none of these fit that model. There's another way of looking at it, though. We can say, for instance, BC over AC equals tangent of 32, because that would be an opposite over adjacent. So BC over AC equals tangent of 32. Well, it doesn't even say tangent of 32 here. So that's also not an option. So we're not getting the sine or the tangent that we want for this. So now it's a moment where we have to get a little creative. This is 90, this is 32, so by triangle sum theorem we know that this one's going to be 58. Now the thing about this is that it changes our angle of record. Now this one is our angle of record, so this is no longer opposite, this is now adjacent, and this one is opposite. So now we can say, for instance, if this is the angle, that the tangent of 58 equals 8.2 over BC. Well, we do see that. We see it right here. Tangent of 58 equals 8.2 over BC. Let's look at it again. This is the angle, and this is the opposite over the adjacent. So the tangent of 58 equals 8.2 over BC. So that must be the answer. We're going to go with C. All right. Last problem is going to be 78. And this one's very wordy, so find key words. A 13-foot ladder is leaning against a brick wall. The top of the ladder touches the wall 12 feet above the ground. So this is the wall. The top of the ladder touches the wall 12 feet above the ground. It's a 13-foot ladder. The bottom of the ladder, right here, is 5 feet from the bottom of the wall. What is the sine of the angle formed by the ground and the base of the ladder? So really, you have to understand the language here. What is the sine of the angle formed by the ground? Okay, well, this is the ground and the base of the ladder. Well, the base of the ladder is going to be right here. So the sine of the angle, what it's really saying is what is the sine of this angle? So we'll call this x. And where's our opposite? Well, our opposite is going to be the wall. And where's our hypotenuse? That's going to be the ladder. So the sine of this angle is going to be 12 over 13, which is right here. Okay, and that does it for number 78. So that does it indeed for Standard 18. Thank you very much. Rewind when you need to. Hi, and welcome to Standard 19. Standard 19, we're going to use trigonometry to solve side length. Let's read the standard. Standard is right here. Standard 19, focus. There we go. Students use trigonometric functions to solve for an unknown length of a side of a right triangle, given an angle and a length of a side. Okay, so the problems associated with standard 19, there we go, are from 79 down to 83. So those are the problems we'll be doing right now. So let's look at 79. 79 says, in the accompanied diagram, measure of angle A equals 32 degrees and AC equals 10. Which equation would be used to find X in triangle ABC? Okay, so this is our angle of record. And X here is our opposite. And 10 is our adjacent. So what we've got is an opposite adjacent problem, or a tangent problem. So the first thing I'm going to do is write this problem. It's going to work like this. Tangent of 32 equals X over 10. Okay, so let's look for that. Tangent of 32 equals X over 10. Okay, problem is we don't exactly see that anywhere. We don't see it like that. What we see is that in each case, X is alone. So let's rewrite what we have to get X alone. We get X alone by multiplying both sides by 10. So there. We cross these out, and we get X equals 10 times the tangent of 32. So that looks like a pretty good answer. Let's see if we see that anywhere. No, no, yes. There it is. C. So C is going to be our answer. Just takes a little patience and you'll get it. Okay, next problem is number 80. The diagram shows an 8-foot ladder leaning against a wall. So here's our 8-foot ladder leaning against a wall. It's always a ladder and a wall, I guess. Okay, the ladder makes a 53-degree angle with the wall. What is the closest to the distance up the wall that the ladder reaches? In other words, how far is this? Okay, well, if this is our angle of record, then we're talking about a hypotenuse here, and we're talking about an adjacent here. So the type of problem we're going to be using, so AH, cosine. So we're going to be doing cosine. So the cosine is 0.60. So, in other words, the cosine of 53, which equals 0.6, equals question mark over 8. So if we want to know what question mark is, we're going to multiply both sides by 8. And the 8's will cross out there. We get question mark equals 8 times 0.6, or 4.8. And there you have it. The answer is certainly B. Okay, so that does it for number 80. 81 now. Triangle JKL is shown below. Which equation would be used to find the length of JK? So we want to know this. So I call this X. You can call it question mark. You can call it N. You can just call it JK if you like. Okay, clearly our angle of record is going to be this one, at least unless something funny goes and we have to solve for this one, which can happen. By the way, you may have noticed this is certainly not a scale drawing. There's no way that's a 24-degree angle. So don't try to estimate by what it looks like. That usually doesn't work. Okay, so our X is our opposite, and our 28 is our hypotenuse. So what we've got here is that opposite hypotenuse is sine. Sine of 24 equals X over 28. Alright, so let's see if there's anything that looks like that. Sine of 24 equals JK over 28. Well, JK and X are the same thing, so that is our answer. Nothing more to it. You're not going to find another one that says the same thing, so that's going to be the one, A. Alright, moving on to number 82. What is the approximate height in feet of the tree in the figure below? Okay, so we've got this angle here, 50 degrees. And we've got 100 feet for our hypotenuse. We want to find the height. Well, the height from there is called the opposite. So what we've got here, again, is another opposite hypotenuse or sine problem. So the sine of 50 equals O over 100. And, of course, we need to use this. So it's going to be 0.766 equals O over 100. So we multiply both sides by 100. When we multiply this by 100, remember, easy way to multiply by 100 has two zeros, so we move the decimal twice to the right, and we've got it. The answer is 76.6. And that will be B. And that's it for 82. Okay, 83. What is the approximate value of x in the triangle below? Okay, not very imaginative, but hey, it's simple, straight to the point. We've got this angle, 35 degrees. Okay, x here is the opposite. This time there is no hypotenuse given, instead it's an adjacent. So, what type of problem is it? That's right, it's a tangent, opposite over adjacent. Therefore, tangent of 35 equals x over 6. So let's figure it out. And it tells us the three things. The one we're going to use is tangent, because it's a tangent problem. So it's going to be 0.7 equals x over 6. We'll multiply by 6 on both sides. And we'll get 6 times 7 is 42. We move the decimal over 1, so we get 4.2. Look for your answer. Bam, there it is. B is the answer. That was 83. That's the end of Standard 19. Thank you very much. Please rewind if you have any difficulty. See you next time. Hi, and welcome to Standard 20. Standard 20 is about special right triangles. Those are pretty fun. That's the 45, 45, 90 and the 30, 60, 90. Let's read the standard. Standard for Standard 20 says, students know and are able to use angle and side relationships in problems with special right triangles, such as 30, 60, 90 triangles and 45, 45, 90 triangles. Okay, so there we go. This is Standard 20. Standard 20, as you can see, is these problems right here, 84 through 86. Just 3 problems. Okay, so we'll start with number 84. 84 says, if A equals 3 square root of 3 in the right triangle below, what is the value of B? Okay, so 3 square root of 3, and we want to know this. Alright, so this angle is 30, and this is 90, so by triangle sum theorem, we know that this is 60. So let's think about our rules here. B equals A square root of 3, C equals 2A. Those are the key ones. There's also C equals, let's see here, 2B over the square root of 3, which is a little bit less useful. So we're not going to worry about this one. Let's see, we have A, we're trying to find B, so B equals A square root of 3, so this one's going to equal 3 square root of 3 square root of 3. Does that make sense? 3 square root of 3 times the square root of 3. Okay, so the square root of 3 times the square root of 3 is 3, so it's going to be 3 times 3, which equals 9. Got it? Okay. 85. What is the value of x in the triangle below? Okay, this one you could actually sort of do with the Pythagorean theorem. And I almost think that's the smartest way to do it, but we'll do it special right triangle style. This one's 90, this one's 45, this one's 45. How do we know that? Well, if these sides are congruent, these angles must be congruent. These angles have to add up to 90, so they have to both be 45. Okay, so what we've got here is this one can be A, this one can be B, this one can be C. And remember, C equals A square root of 2. So if we know C, then what we can write is 10 equals x square root of 2. Simple substitution, right? 10 equals x times the square root of 2. So then what we've got to do is divide by the square root of 2. And we get x equals 10 over the square root of 2. But you can't ever leave an answer like that. You've got to do what's called rationalizing the denominator. So what we're going to do is multiply by the square root of 2 on top and on bottom. What happens is that these multiply to make 2. So then we get 10 square root of 2 over 2. The 10 and the 2 cancel to become a 5. The final answer is 5 square root of 2. 5 square root of 2 is B. So that's your answer. Okay, that one was a little tricky. Rewind it if you need to. Last one we're going to look at is 86. What is the value of x in inches? Okay, so here we have 30, here we have 90, so that means this one has to be 60, right? So remember in your 30, 60, 90s, again, B equals A square root of 3, C equals 2A. Those are the good ones to know. If you know those ones, you can pretty much make anything happen in a 30, 60, 90 right triangle. Alright, so this one, well, this must be A. Just to be sure, it's across from the 30, so it's across from the smallest angle, therefore it must be A. This one has to be B because it's across from the 60, and this one's C. So basically we're using A to find B, So b equals a square root of 3. So if a is 7, this one's going to equal 7 square root of 3. No alterations needed, that's the answer. So the answer is a, 7 square root of 3. All right. That's it for Standard 20. Quick and dirty. Make sure to rewind if there's something you don't get. You want to understand it completely, not partially. Thanks, and I'll see you in Standard 21. Bye. Hi, and welcome to Standard 21. Standard 21 is all about circles. Let's read about it. Standard 21. Students prove and solve problems regarding relationships among chords, secants, tangents, inscribed angles, and inscribed and circumscribed polygons of circles. Holy moly. Okay, so here is Standard 21. Standard 21 is going to be problems 87 through 92. 87 through 92. So the first one we're going to look at is 87. It says a square is circumscribed about a circle. What is the ratio of the area of the circle to the area of the square? Okay, so the square is circumscribed. So remember, there's inscribed and circumscribed. So circumscribed means on the outside. So that means the square will be on the outside. So the circle will be on the inside. So instead of just giving you the answer, I'm going to kind of prove this. Let's say that this distance here is both the side length of the square and the diameter of the circle. Okay? So if that's true, then this has to be 2r. Right? The side length has to be twice the radius. So the circle is going to be pi r squared, and the square is going to be 2r squared, which equals 4r squared. Does that make sense? So the circle is pi r squared, the square is 4r squared. So it says, what is the ratio of the area of the circle to the area of the square? Well, the ratio of this to this, pi r squared over 4r squared. Let me just cancel this part out. And what do you get? Pi over 4. There it is. D. Okay. 88. In the circle below, segment AB and segment CD are chords intersecting at E. If AE is 5 and BE is 12 and CE is 6, what is the length of DE? So we'll call this X. Alright, so this one is pretty tricky. It doesn't lend itself to easy solution if you don't know how to do it. But I thought of a way to explain it. These are obviously vertical angles. So what we've got here is that this angle is congruent to this angle. This angle is congruent to this angle. We've got here is similar triangles. Alright? All you got to really understand is that corresponding sides are going to be proportional. In other words, 6 over 12 equals 5 over x. 6 over 12 equals 5 over x. Okay, so 6 over 12 reduces to 1 over 2. And you can cross multiply to find x. So x times 1 is x. 5 times 2 is 10. Okay? The other way to think of it, quite simply, is that you can always set up a proportion with intersecting chords. The sides on one side of the intersection will be proportional to the ratio of the sides on the opposite side. So 6 over 12 equals 5 over x. The stuff with the similar triangles only helps prove it, that's all. It doesn't help solve it. Okay, so there you go. The answer is C equals 10. And that is number 88. Moving on to number 89. 89 says that line RB is tangent to a circle whose center is A at point B. Segment BD is a diameter. Okay, so here's your diameter, and this is a tangent. So, of course, that means this is a radius, and as we remember, tangents are perpendicular to radii. Other things we know is that if this is 25, then this angle here has got to be 65 degrees. What is the question? The question is find the measure of angle CBR. Oh, I accidentally solved it already. Got it? Good. 65. And you know, that's kind of a good strategy actually. Put in everything you know, and sometimes you'll have this problem solved before you even start thinking about it. That can be good. In the figure below, segment line AB is tangent to circle O at point A. Secant BD intersects O at points C and D. Measure of arc AC equals 70 degrees, and measure of arc CD equals 110. Okay, the nice thing about this problem is that they tell it to you in words, but they also show it to you in the diagram. Let's see, if only we knew the measure of this arc, then we could do arc minus arc divided by 2 equals the angle, right? Because we're trying to find the measure of angle ABC. We're trying to figure out this. So the question is, do we know this arc? Well, you can think, gosh, if that was a diameter, it would be a 180 degree angle. But that might not be sufficient proof. Here's what is sufficient proof. This arc here is 70. This arc here is 110. 70 plus 110 is 180. So if this arc is 180, guess what? This arc is also 180. Why? Because circles have to add up to 360. So if this is 180, now we've got a pretty easy problem. 180 minus 70 divided by 2 equals x. Let's write it down. 180 minus 70 divided by 2 equals x. 180 minus 70 is 110. Divided by 2 equals 55. C is our answer. Okay, that was number 90. Next is number 91. 91. It says, in the circle below, the measurement of arc PR is 140, and the measure of angle RPQ equals 50. Okay, and it's saying, what is the measure of the arc PQ? So we want to find this one. All right, so let's look at this. This is an inscribed angle. Does everybody see that? It's an inscribed angle. So let's think about this. If that's inscribed, what about this one? That's a central angle. And remember, central angles equal inscribed angles times 2. So if this one's 50, then this one's 100. And if this one's 100, then this arc is 100. And if we're trying to find the measure of arc PQ, then let's look at this. We got 140, we got 100, and we got x. And it's a circle, so it's got to add up to 360. So 140 plus 100 is 240. Therefore, 360 minus 240 equals x, which is 120. Not so bad. Got it. Okay. Next is 92. Segment QS is a diameter of the circle below, and segment QS is perpendicular to PR. So we know that this is a diameter, and these are perpendicular. Okay, if measure of arc PQR equals 106 degrees, what is the measure of arc PS? Okay, so PQR is 106. Okay. And what is the measure of arc PS? So we're trying to find this. Okay. So this looks like a little bit of a challenge. If this is a 106 degree arc, then we know that the central angle attached to it is also 106. We also know that these are perpendicular, so that this is 90, 90, 90. So then this is going to be 53 and 53. So then this angle here, see, 53, 53 to make the 106. So this angle here has got to be 127 degrees. And of course, this central angle has to be congruent to the arc attached to it. Therefore, x is also 127. Not so bad. Okay, so that's it for circles. That was standard 21. Rewind if you need to. Make sure to go over it enough times so it really sticks in your brain. Okay, I'll see you in the last one, standard 22. We're almost done. Bye. Okay, welcome to standard 22, transformations, the last one. Let's read about the standard. Here it is. Standard 22. Students know the effect of rigid motions on figures in the coordinate plane and space, including rotations, translations, and reflections. And this will be comprised of problems 93 through 96 in your packet, the last 4 problems. So let's look at number 93. Ooh, lots of reading. The vertices of triangle ABC are A, 2, 1, B, 3, 4, and C, 1, 3. If triangle ABC is translated 1 unit down and 3 units to the left to create triangle DEF, what are the coordinates of the vertices of triangle DEF? Alright, so when we see 1 unit down, that tells me y minus 1, because that's 1 down. And 3 to the left, well, that's going to be x minus 3. It's important to get the sequence of these, because even though it told us the y first and the x second, we know that x always goes before y when you're writing your translation. So x minus 3, y minus 1. So what I'm going to do is I'm just going to translate these mathematically one at a time. So if A is 2, 1, D is going to be, because D corresponds to A, 2 minus 3, which is negative 1, and 1 minus 1, which will be 1. So there's D. E is going to correspond to B. So B is 3, 4. So 3 minus 3 is 0, and 4 minus 1 is 3. So we got negative 1, 1, 0, 3, and lastly F. F is going to be C translated. So 1 minus 3 is negative 2, and 3 minus 1 is 2. So we're looking for negative 1, 1, 0, 3, and negative 2, 2. So negative 1, 1, no. Negative 1, 1, no. I'm sorry. Did I just write? Oh, I wrote the wrong number. It was 0, wasn't it? Oh, that's such a silly mistake. A, go back to this. 2 minus 3 is negative 1. 1 minus 1 is 0. I don't know why I wrote 1. I'm sorry. Okay, anyway, negative 1, 0. Still no, still no, still no. Yes, okay. E is 0, 3. Check. F, negative 2, 2. Check. It's got to be D. Okay, sorry about that mistake. Hope you can forgive me. Alright, number 94. If triangle ABC is rotated 180 degrees about the origin, what are the coordinates of A prime? Well, we need to rotate 180 degrees about the origin, but here's the thing. The only point we actually have to rotate is A. So let's make a vector here. Whatever this vector is for 180 degree rotation, you just do the exact same vector on the opposite side. So the x component here is 5, the y component is 4. Therefore, we'll go 5 and 4. And we'll come to this point, which is an exact 180 degree rotation. So the coordinates will be negative 5, comma, negative 4. A. That's 94. 95. Trapezoid ABCD below is translated to trapezoid A prime, B prime, C prime, D prime by the following motion rule. X plus 3, y minus 4. What will be the coordinates of vertex C prime? So let's take C, and we're going to put this into x plus 3, y minus 4. So x plus 3 will be 3 to the right, 1, 2, 3. Y minus 4 will be 1, 2, 3, 4. Down, this will be the coordinates. That's going to be 8, negative 3 for C prime. 8, negative 3. There you have it. It's D. Okay, that was problem 95. Oh my gosh. Last problem, and then we're done. Which expression describes the translation of a point from negative 3, 4 to 4, negative 1? Well, from negative 3 to 4 is going up. It's going up by how many? Well, it's going up by 7. So it's x plus 7. From 4 to negative 1, that's going down. It's going down by how many? It's going down by 5. So that's going to be y minus 5. X plus 7, y minus 5. That's what we're looking for. Oh, okay. 7 left. Yes, because plus is no. That's going to be 7 right. because plus is right, and y minus 5, 5 down. 7 right, 5 down. Let's look for that. 7 right, 5 up, nope. 7 left, 5 up, nope. 7 left, 5 down, no. 7 right, 5 down. There it is. We are totally done. Yes! All right, that's it. That's the entire star packet done for you. That was standard 22. If you've watched the whole thing, you've really done a great job. Good luck on